Hi, I'm DJ Ware, and this time on the Cyber Gizmo, we're going to be looking at Logical Volume Manager. We're going to do a demo, going to step through it a little bit and explain a couple of different things to you on how it works. So stay tuned right after this. Okay, so let's get started. I've got a window here, and I'm going to show you what I have done so far ahead of time to prepare. So I'm going to go into fdisk. You guys laugh at this all the time. So just to remind you, fdisk is not Windows. Doesn't have anything to do with DOS. Fdisk actually came from Unix. just so you know that. So it's much older than you think. All right, so what have I done here? So as you'll see that I have, this is the system drive, this is SDA, and I haven't done anything to do with that, but there's a LVM that's installed on here by default by the system when I installed it. The next one is, you'll see SDC. These are some of the drives I've set aside to use with LVM. So the first thing you'll notice is that it's a partition type GPT. And the second thing you'll notice is that I have gone ahead and created a whole drive partition. So there's a number of reasons for that. Basically, if I can use the whole drive, I mean, I could assign the SDC to the drive pool, but the problem with that is that if I start to put on structures that write redundancy information, the LVM could get confused and think that it's writing to one of the other drives, and it's not. It's writing to the same drive, so it might have two pieces of redundancy information on the same drive. Well, that's not a good idea, because if you crash, you lose your redundancy information, and then you lose your RAID. So I do it this way so that there's no confusion. You can't confuse LVM, and it'll know, hey, that particular drive that whole partition is allocated, and there's no chance that there'll be another file system on this. So yeah, all right. So how do we do this? So what's our first step here? So the first step is get a whole volume partition assigned to the drive. The second step is we want to do a PV create. So what do we need for that? So the first thing you'll find here is these pretty much all follow the same kind of construct. So you'll need the name of the actual physical device, and that's it. So in order to do this, I do a PV create, and then I'm going to assign. Now I could do that, but I'm going to assign the partition, and then I'll just go on to the next one. Now I could leave one of these off. Yeah, we'll go ahead and leave one of them off for now. All right, so we've now taken, out of our 4 drives, we've now taken 3 of them and assigned to the pool. So what does that look like? So it knows that each one of those is 32 gig, because that's the size that we defined in our virtual machine. So these are all coming off the same physical disk. So there's no advantage here for bandwidth or anything like that. This is just for today to play around with something that we can show the commands and how to use them. All right, so then it shows you the physical size, P size and P free. P size is the maximum, how much storage that drive has, and then P free is how much of the drive storage is left. So yeah, so let's go ahead and the next step is we'll need to do, let's do the man again on VG create. And you'll notice there's just tons of options here. You can manage almost anything, everything down to the gnats, the gnats toenails. So, yeah, and be careful with that one. So, all right. So, how do we do it? We do a VG create. we have to give it the name of the volume group. So we have to create one. So let's see, let's just call this D group for now. And then we'll start assigning the drives. Now this is coming from the PV, not from, this isn't coming from the physical device. This is the ones we've allocated. So just, there is a difference, and I just want to make sure that you're aware of it. Because if I pick one that isn't here, it will tell me. You'll notice I got this warning, and I got it before too, so let me explain what that is. So it's saying device file dev SDB is excluded by filter, and the device is partitioned. So it's just telling me, hey, be careful, you don't want to allocate this whole drive because you already have a partition assigned, and that could result in data loss. So yeah, so all right, now what does that look like? So let's do a VGS. And that shows me the virtual size. So altogether, all of those drives in D group are allocating 96 gig essentially. And of that 96 gig, it's all free. 96 gig is available for use. Okay, fair enough. So now we need to go to the next step. So now we need to do a LV create, and we can do a man on that one too. This time you're going to find a lot more options than this, and let me just go through here. So you'll notice the first thing it shows how to create a linear LV. That's what we're going to do. A linear LV is just concatenating these drives together to create space. That's what we did in the group. We took all those drives and we just concatenated them together in the volume group. So yeah, so that's how you create larger spaces out of physical drives, as you just add them on to the ones in front. So that gives you all the stuff you can do there for defining it. And then there's some for like a stripe. There's a RAID 1. There's a regular RAID, RAID 10. There's a copy on write. There's a thin pool. Thin pools work just like they do for a hypervisor. So it only allocates the disk space from the pool when you write to it. Whereas what I just did was basically a thick, which allocated all the space when I pulled the drives into the volume group. The volume group. And now the LV create is going to allocate all of the space it needs based on the parameters that it passes. So, okay. We're going to give this 10 gig. L is the size. And then I have to give it the name of the group, which in my case is D group. And then it created the pool. And this time you see the L size is 10 gig. So right here, the L size is 10 gig. I could also do, I can get additional information back as well on it. All right, so as far as the volume group is concerned, we're done. So where did it put that? So you're going to notice that there's a D group out here. This got created. So that's my volume group. And in there is my logical volume 1, and that is pointing back to DM2, which is, these are my physical devices that I have pooled together. So, all right. So, and those are block devices. If I do, yeah, you'll see that that's a block device. All right. So the next thing we need to do is we need to make a file system on that drive. And you'll notice I'm putting in a device name, and this time we're using D group and LVOL1. Okay, and it's done. Now I'm ready to mount it. Same thing. and then tell it what directory you want to mount it on. And we should be good to go there. Okay? So, all right. Now, how did that allocate out of the pool? So it took 10 gig out of the first, out of SDB. Don't ignore SDA. These are the 3 drives in our pool here, and you can tell they all say D group under them. So it allocated 10 gig, and it took it from the first drive. It didn't take any from the second or any from the third. So that's the way it will assign data. So I can extend this. So let's extend it. And we'll go L plus 22 gig. We're going to take the rest of it. And this time I'll do the other way of defining it. So, got to get the D on there. And now it has resized it. So let's see. How did that affect the pool? So it took all of the first drive now. But one thing you'll see, I'm still at 10 gig on my SRV. So what do I do here? Well, I need to do an XFS grow FS. And you can use the mounted file system for this. Let me do something before I do this command though. Let me go out here to SRV. I always forget the DD. Let's do this DD command right here. That'll put a files. Okay. Okay. Let's do an H so I can read it. All right. So you'll see that I have a 1 gig file called test. So now I want to do a So first, it hasn't done anything to change the size of that pool. It still says it's 10 gig. Oops. It's still 10 gig. So now I want to grow the pool. So we'll do an XFS, grow, FS, SRV. And now it tells me that the blocks have changed from 2,621,440 to 8,388,608. So we should have 32 gig now as my total size. So you can do this with ext4 as well, but there's a couple of extra steps to do that. You will need to do an FS check, and you can't have a file system mounted when you do that. As far as doing then you do a resize to FS, and that will allow you to resize the partition, so without data loss. So again, I haven't lost any data. Oops. There's my test file. Should be all zeros. Well, let's do an OD. So the first thing we'll want to do is to unmount SRV, because we won't be able to do anything with it mounted. You can double check it's gone. And now we can do LV remove. And I need to put in D group, LVOL1. So that's one way of doing it. I'll go ahead and say, no, I don't want to do that. The second way of doing it is that way. You put in the volume name first, followed by the group, and it's successfully removed. So yeah, that's gone. So I can do an LVS, it's gone. I can do a VGS. The free has been updated, so all that data is now back in the group. And you can see that PVS also, all that is back in the group. But those devices are still assigned to D group. All right, so let's leave that group alone, and let's create we're going to do an LV create. This time we're going to tell it it's a type RAID 5. And I want to specify use all available data space. No sync. And I'll give it a name. And it's created my RAID for me. It's allocated 100% of it because there's no V-free left. And it shows me of that pool size of 96 gig, I have 64 gig left. And where'd the rest of it go? It went to that one drive goes to, a full drive goes to the redundancy. So yeah, you lose a full drive to redundancy. All right, so let's go ahead and make a file system on it. Do an XFS again. Now I'm going to mount it. Got to go find my DD command. There we go. It's able to write to it. And it's telling me that out of the 64 gig, I've used 1.5 gig. So again, that's a 1 gig file. Where did the rest, what's the rest of that? Well, it's the integrity information, again, that is taking up that size of the pool. So the 1 gig comes out of the available, but the ½ gig comes out of the other drive that's been assigned. So if I do, they're all taken. And yeah, it's all my free space is used. It's right here. All of it's used. So that's how that works. Again, Red Hat does not publish the instructions to do this anymore. So if you use RAIDs, go with caution. You will notice that a lot of people will, well, I wouldn't say a lot of people, but I have seen recommendations that do not use LV RAID. Use MD ADM for a software RAID first and then put your LVM down on top of it. My problem with that is that's really surrendering all of the advantages of LVM because you now have lost the management of the array. So yeah, and that's unfortunate. There is one other thing that you should know about, and that is you should scrub your drives periodically on RAIDs to make sure that you don't have any bit rot. So and I'm just, these are the name. This is copy. percent. This is just metadata, and then devices, and then this goes to D group, and then it will go through and do a basically a scrub of the drive, and that's how fast it completed. So it didn't take very long. You'll notice there that there's actually an R image and R meta for each one of the drives. So the R meta is the metadata that's associated with the drive, and then the R image is the actual data. So yeah, you can think of the R meta as the redundancy information, and that's stored on all three drives. So that way, if one of the drives fails, it doesn't matter which one it is. It's able to reconstruct what's missing from the remaining metadata that survived. So I hope you enjoyed this look at the Logical Volume Manager today. What we did was we first went in and checked to see whether or not our physical devices, now I don't mean the ones that are assigned to LVM, but our real physical devices have a whole disk partition on them, and explained why that's a good idea to do that. And then second, we assigned all those whole disk partitions as physical volumes to LVM. So we just basically took them and assigned them. The next thing we did was we defined a group out of that pool of physical drives that we wanted to be able to use to create different file structures that we could then manipulate and use going forward for storage. Then we looked at what is called an LV linear, and so a logical volume linear is a drive that is made up by concatenating physical drives together until you get the size of the data pool that you want to use. And I showed you how you can expand them. I didn't show you how you can shrink them. There's some caveats to that, and I personally, in this, why would you be shrinking data files? But anyway, yeah, unless you just made a mistake, the best thing to do would be to just recreate it. None of these substitute for backup, so you still won't have to do your backups. Then the next thing we did was we created a volume group out of that pool of physical devices, and then we took and carved out that. We took that volume group and we created a logical volume that we could then put a file system on and mount. So that's basically it. The next thing we did was we looked at how to create a RAID. I did warn you that Red Hat no longer publishes how to do a RAID in their latest versions of their manuals for RHEL 9. So be careful. There's probably a good reason for that. They didn't admit it because someone wasn't there that day. They were probably admitting it because there have been problems with RAIDs on LVM. So yeah, they can be cantankerous and you can lose data. So if you choose to follow this video, do not put this into production and use it for your personal workloads for your favorite photos of your children and the kinds of data that you want to keep. Treat it as an experiment. So that's the best advice I can give you on it right now. I don't know if Red Hat ever has the intention of bringing it back or fixing the problems with it, but whatever it is, I would leave well enough alone. We also talked about some of the recommended ways that you will hear others talk about. That is, actually create the RAID first, and then lay your logical volume structures down on top of that. So the only problem I have with that is that yes, that will work, but you're really giving up all the advantages of LVM, except for one, is that you could hold back free space and be able to expand it if you need it. But being able to just add devices to the pool, you wouldn't be able to do that because all your RAID functions are now front-ended. So if you're gonna, personally, if you're gonna do this, I personally would look at ZFS for my RAIDs, or I would look at a hardware card for my RAIDs. Either way, that's probably the way I would be going for this. So with that, I hope you enjoyed this video today. Please like and subscribe, and hope to see you again very soon in the next one. Bye for now.